there, folks. We're back again today. We're trying to solve two-step equations. We already talked about how to solve one-step equations using all of our operations: addition, subtraction, multiplication, and division. Today, we're going to talk about what happens when you can't just do one of those and get your answer. So let's start off today with our I can statement. It says, I can manipulate and solve equations that have multiple steps. By the end of this lesson, you want to be able to say that. If you can say that, then we've been successful. Alright, first things first, a two-step equation is this. It's an equation that contains two operations. In order to solve two-step equations, use inverse operations to undo each operation in reverse order. So what we saw before today were, problems like, whoops, that's supposed to be a 3. 3x equals 6. And all you had to do is divide by 3 on both sides. It took one step to solve it. Now, we're moving on to something where obviously you're seeing there are going to be more than one operation that you have to perform. Okay? Our definition says that we need to use inverse operations to undo each operation. Well, we've already been doing that. 3x equals 6, we solve it. Okay, since 3 is multiplied by x, we did the inverse of multiplication and we divided by 3 on both sides. Wow, this guy's not working very well. And we divided by 3. Okay, that is the inverse of multiplying. So we are left with x equals 2. Simple enough. Alright, so to our two-step equations, we're not changing anything other than we have to do an extra step. However, you need to remember one thing. When you solve multiple step equations, you need to do the operations in reverse order. So when we're solving with PEMDAS and we're simplifying an expression, normally we do everything that's in the parentheses, and then we multiply, or we do our exponents, and then we multiply, and then we divide, and the last things we do are add and subtract. But in multiple step equations, when we're trying to get a variable by itself, we're going to reverse that, and we're actually going to do the multiplication or the addition and subtraction first. We're going to try and get rid of everything that's on the same side as x, but we're going to get rid of everything that's not attached to x first. In this case, I say the 3 is attached to x. Over here, I would say our 3 is attached to n. So let's get rid of everything that's not attached to x first, and then our last step will divide. So what do I mean by that? Let's get rid of this minus 4 on the left side. Let's get it to the right side, because we're obviously trying to do everything we can to get x alone. So by adding 4 over here and over here, we're left with 3x equals 21. And now you're left with a basic one-step equation. All you have to do, divide by 3. So your final answer should be x equals 7. Question is, does that check? Well, let's check it really quickly here, because you should always check. Oh, that should not be an x, that should be a 7. Minus 4 equals 17. So 3 times 7 is 21, minus 4, and that equals 17. So it checks. So your answer is correct. Okay, as we come over to number 2, once again, we're trying to get n by itself. So that means we need to get rid of our 3 and our 8. But I've already told you, before we multiply to get rid of the 3, we're going to subtract to get rid of the 8, because the 8 is not attached to the n. But we need to get it off the right side so that n's by itself. So here we go. In order to get rid of a plus 8, we're going to subtract 8. And we're left with 3 minus 8 is negative 5 equals n divided by 3. Okay, now you're left with a basic one-step equation. How do you get n by itself? What's the inverse operation of division? It's multiplication. So you've got to multiply on both sides by 3. So those guys cancel out, and you're left with n equals negative 15. Once again, you should check your answer. For time's sake, I'm not going to do it here. All right, on to 3. It says the formula F equals 1.8 C plus 32 is used to convert Celsius degrees to Fahrenheit degrees. Solve the equation to find the equivalent Celsius temperature for 59 degrees Fahrenheit. Well, in case you didn't realize it, F in this equation represents degrees Fahrenheit, and C, of course, is going to represent degrees Celsius. So that means if we knew a degree temperature in Celsius, we could just plug it in for C, simplify this guy, and it would tell us how warm that is in degrees Fahrenheit. But that's not what we're given. It says solve the equation to find the equivalent Celsius temperature for 59 degrees Fahrenheit. So where do you think you plug this 59 in? That's right, you got to plug it in for F and then solve for C to find the Celsius temperature. So let's do that. That's not going to give me enough room. I'm going to start up here. So I'm going to plug in 59 for F. 59 equals 1.8 C plus 32. And here we go. We just have a multi-step equation. We're going to solve it just like we did the ones up above. We're trying to get C by itself. So first thing you should do, can we get rid of anything on the side of C that's not attached to C? Well, the positive 32 is not attached to C. So let's do the inverse of adding. Let's subtract 32. Got to do that on both sides. So here's this. Those guys cancel out. 59 minus 32 should be 27. That's going to equal 1.8 C. And here you are, left with your one-step equation. This is 1.8 times C. So how do you undo multiplication? What's the inverse operation? It is division. So divide by 1.8. Of course, you got to do that on both sides. Once again, you would probably have to do your long division, 27 divided by 1.8. But for time's sake, I'm not going to do that. So C equals 15 degrees. How do you check that answer? Please bring it all the way back to your original equation. 59 equals 1.8 times 15 plus 32. And then you simply simplify that guy and make sure the left side and the right side are equal. As it turns out, we did this correctly. So you should get 59 equals 59. It checks. So that guy is your answer. Alright, let's move on to the next slide here. Number 4, I'm going to ask that you do this on your own, as well as number 6, and bring those into class tomorrow. I'm going to do one more with you, number 5 here. This is slightly different than what you've seen at the top, only because before you start solving, before you start eliminating anything off the same side as B, there's something you can do to make this easier on yourself. You have B minus 3B plus 8. Well, we've done this in previous sections. You can combine your like terms to make this simpler. So B, or 1B, minus 3B is negative 2B plus 8. So you've just, and of course they still equal 18. You've just made this equation a little bit simpler on yourself before you start doing anything. Okay, so now we want to solve for B. How do we do that? Well, we first eliminate anything that's not attached to B. So since we have plus 8, let's do the inverse and let's subtract 8 from both sides. And you have negative 2B equals 10. And our last step then, how do you undo multiplication? You've got to divide by a negative 2. Don't just divide by 2, it has to be negative 2. The negative 2's cancel out, and you're left with B equals 10 divided by negative 2 is negative 5. Folks, you should be able to check that on your own. Take it back to your original equation, plug it in for b, you should get 18 equals 18. Alright, to sum up, if there's anything you can do to simplify your problem before you start solving, for instance, maybe combining your like terms, you should do it. It's going to make your life easier. So like in number 5, we combined like terms because we could. In our first couple of examples, there was nothing you could do. So okay, skip step A. Part B, when solving an equation that has multiple steps, remember, you've got to undo all the operations that have been performed on your variable. Okay? All I'm saying is you need to work backwards. So in number 6, make sure you get rid of all the things that are not attached to y first. And then your last step should be to undo your -8. Alright folks, hope this is helpful. See you in class.